Well, good afternoon, everyone, and welcome to the final of our GenLess webinar series. Today, we're joined by Gordon from LPINZ around a fascinating topic for me, which is EV chargers. I mean, EVs are a wonderful, wonderful thing, of course, for all sorts of reasons. But if we have EVs, we've got to have EV chargers. And there's a lot more to putting an EV charger in place than simply plugging it into the system. Gordon is going to go through that. There's a lot of detail around there about what you really need to know before you actually go about installing EV chargers and the things to think about before you start installing them. So I won't take up too much of your time, but we do have to go through a little housekeeping. I had a chat with Gordon before we switched the broadcast on, and he's asked that we take questions at the end of the session. Usually that's the better way to do it, because what we tend to find is that people ask a question and then 2 or 3 slides later the question would be answered anyway. So if you'd like to submit a question for Gordon, then please write it into the question box that you should see on the right-hand side of your screen, or you can press the raise the hand button, and I'll be monitoring those, and when Gordon finishes speaking, I'll individually open the microphones of the person to invite them to ask their question. At the moment, all your microphones are defaulted to mute, and that's simply to avoid lots of feedback or background noise when Gordon's delivering the presentation. But as I said, when we actually get to questions, I'll unmute the microphone so that you can ask them in person in case there's a follow-on that you wish to ask as well. So I think that's enough from me. I'll hand you over now to Gordon, who will take you through the intricacies and the nuances and all you really need to know about setting up EV chargers. So over to you, Gordon.
Thank you, Mike. Good afternoon, everyone, and thank you very much for giving us time to present the EV chargers. And we will start with EV chargers and what is important to make good decisions at the start. I'm just trying to get rid of this camera. First of all, good afternoon. As Mike said, my name is Gordon Luetic. I'm from LPINZ, and we'll talk about the EV chargers and also around what EV chargers are influencing and how do they impact the energy systems as well. As Mike mentioned, what we'll do is we'll cover areas on how to choose the right EV charging solution and how we're gonna correctly identify what the installation needs to be and what's the capability of the existing installations and how do we choose the quality products to install and what are the areas on the safety issues that we need to decide on, and also what's the ease of use and revenue management, what would be return on investment, and also as a final thing, what is the that you need to be careful of product support, warranty, maintenance, and so on. First of all, I would just, as I said, introduce our company. We are LPINZ, and we initially started business about 11 years ago on lightning protection, surge protection, and earthing, and majority of you people would know us in those areas. But since then, we expanded quite a bit into earthing and also into the areas of power monitoring, so we can provide that sort of service as well, and also on the power quality, on the UPS systems, power factor correction, harmonic filters, and the topic that we'll be discussing today is EV chargers. Just to give you a little bit of a background about us and areas that we've been involved in, either EV charging systems and different other products that we produce that we can offer, is like Atrium Car Parks, Victoria Street Car Parks, Rocket Lab, Sky TV, Sky Tower, and various other important facilities like Airways Auckland, Airways Christchurch, and so on. We're also involved in the international areas, especially in Pacific, so we supply a number of equipment, not so much demand on EV chargers in those areas at the moment, but we are covering the power quality areas in these areas. Because of the quite a bit of demand for the power quality systems, in addition to our originally systems like for lightning protection, earthing, and exothermic CAD welding, we started recently a new division in a company called Power Quality International, and that would be focusing only on the power monitoring, power issues, and so on. Talking about EV chargers, it is important that we are aware of the implications that possible EV chargers, especially bigger size EV chargers, will introduce on the total energy situation of any facility. So it is important that we assess what are the implications by adding EV chargers. First of all, do we have enough capacity in the building? And also there are some hidden areas, like for example, harmonics, which especially if you're introducing new big DC chargers, either 50 or 150 kilowatt chargers, they will introduce the harmonics in the system, like any other switch mode power supplies. So it is quite important that you address these situations before you make decisions on what charger to use. The harmonic issues with the chargers are they generally produce about 30% harmonics distortion, and it is, as I mentioned, it is quite important to address these things. What we can do is, these are some of the services that we can offer, but whichever way you decide to go, it is always advisable to do the power audit to find out exactly what the situation at your facility is. Which means that you should do the energy efficiency studies and power factor and harmonic studies, and then find out who can provide the report for you and assess the whole situation. There's a number of different ways that you can conduct the power analysis, and including the harmonic analysis, either by fixed power analyzers or portable power analyzers. For those of you that are not familiar with harmonics, I'll just quickly go over it. And especially for the facility managers, it's quite important to realize that harmonics can cause some quite serious problems. So if you're introducing, let's say, 2 or 3 big DC chargers at your facility, there is possibility that you would introduce harmonics, and harmonics in the system can produce cable overheating, and they can become also the potential fire hazard as well. So it is important that you know exactly which way you're heading and what will be the final result of your installation. We can assist, and we did assist to a number of different companies by assessing the situation and seeing what's the capability of the system, and if they're introducing EV chargers, what are the options to successfully introduce number of required chargers. Again, just for those of you that are not aware of the harmonics, I understand there are a number of facility managers present to this presentation, and they are not electrical engineers, but basically harmonics are just multiples of the fundamental frequency. Most of you would know that our standard power is rated at 50 Hertz, so third harmonic would be 150 Hertz, or fifth harmonic would be 250 Hertz. And those harmonics are actually introducing what we mentioned earlier, possible overheating of the cables that can cause potential fire hazard, and also it can cause nuisance tripping of the breakers, and it can cause some other problems, but we won't go into those details. We can leave that for other presentation. The idea is just to give you an idea whatever is connected with the EV chargers and harmonics. Types of loads, like for example, you can see here that in this situation, there's no harmonics in this system because these are linear loads. So linear loads, you don't have any problems with it as long as you got the resistive loads, induction motors and transformers, they would not cause the harmonics. While if you use either EV chargers or VSD, variable frequency drives, and switch mode power supplies, they would cause the harmonics, and they can cause these problems that I mentioned earlier. Now getting back onto the more onto the EV chargers, and as we mentioned earlier, how to make good decisions at the start, which is like with anything, it's important to assess the situation before we go into the installation. So it is important to assess the what type of the facility are we dealing with? Are we working with the parking lots? Are we working with the supermarket areas, apartment buildings, and so on? And what are the requirements that you might need for the EV chargers, and also for the software that might be associated with? In short, also you want to know what are the ways that you can possibly, if you're introducing EV chargers, that you can invoice customers, and what are the abilities to save costs while installing it. So we'll address some of these areas as we go on. So with the EV chargers, as we mentioned, this presentation is more around the EV chargers and type of installations. So we won't be advertising any brands or anything like that. So removed any brand names, but we'll just go quickly over it on different types of EV chargers. Like for instance, is there a requirement for RFID cards that you can, for example, recently what we did installation for the apartment blocks, where you can have different tenants that can have their own RFID card, and they can basically, when they need to charge the EV car, they would just swipe their card, and automatically our backend system will recognize it, and that charge will be allocated under that RFID card. So the landlord can, at the end of the day, produce everyone with their own invoice for whatever power they used. This last charger also got the Bluetooth capability. I'll go in a minute a little bit more about this. But this specific charger is the basic what they call it e-home. It doesn't have any RFID card, so it's a basic charger. They start from 3.5 kilowatt. And they go up, I believe it's around about up to 12 kilowatts, and pricing starts around about $650. That's including the plugs and the unit itself. But then of course we go up to the big DC chargers that are priced at tens of thousands of dollars and so on. But again, I just mentioned just to give you some idea of the pricing range, but again, we won't be talking any specific about any brands or any advertising any particular units. The Bluetooth type EV chargers, the advantage is that you can basically plug it in and virtually start the charging from your car, so you don't have to be even close to the car, and you can monitor that charging. You can see exactly through the free app. You can see how full the car is, how much is still remaining, how much remaining time do you have until the vehicle will be charged, and so on. So this is just to give you an idea of what different apps are available in the EV market areas. Then there are, again, it's important to consider when you're installing the chargers, where you're gonna mount the charger, where is it gonna be installed. So our technician would usually go on site and assess the situation. If we can, or if the requirement of customer is to install it on wall, we will of course do that. But if sometimes there's no wall available for the area where you're trying to install it, so you might be supermarket area or parking lot and so on. So then this pedestal type of EV chargers are available. So then again, you can use part of this pedestal also for the advertising of your company, or you might offer some other services and so on. So this particular type is, as I mentioned earlier, it can communicate with Bluetooth. So for instance, you can come to the supermarket, plug your car in, and start your shopping, and in the middle of your shopping inside the supermarket, you can just have a look at your phone, and the app will tell you how full is your car, how much is still left to to charge it and so on. And you can start and stop charging as well. Now we move on to different types. So these other chargers with sort of like a small area. These chargers are still, that you can see on this slide, they are still not big DC chargers, but they are still AC, and they are available, I believe it's up to 22 kilowatts. So you can have 22 kilowatts charger on each side of this unit. So you can see here A and B plugs. So one socket A is on one side, socket B is on the other side. So again, you can give this sort of RFID card to tenants in apartment B and tenant in apartment A, and they can use the same charger, but it will be two different invoices. If you have a bigger area that you're trying to service by your EV chargers, then one very cost-effective way of doing it would be to provide cost savings, would be to use master-slave configuration, which means that so the first unit that would be master one is sort of unit is at the standard price, and it would have a modem situated inside for remote connection, and it would have all the software and protocols inside, while the other units that are slave, they would be much simpler units, but they would all be communicating with this master unit. So this sort of installation would obviously, especially these days, everyone is interested in reducing their costs. So again, we're reducing the cost by avoiding that duplicating that smart hardware that will be situated only inside the master unit. Operation cost, obviously you don't need to have a modem in every single unit. You can just have a modem in the master unit, and master unit will communicate with the other slave ones. And the installation cost, there would be, if you need any upgrade or anything like that, you just upgrade it on this master unit. Majority of the EV chargers these days, they come with the OCPP, which is Open Charge Point Protocol, and which means that basically, that's one important thing to address, is when you're choosing the EV chargers, that you ask the supplier to ensure that it is OCPP compliant, which means that you can that you have one software that can communicate with different brands of other chargers. Now, in our systems, even though if any of the chargers are not having OCPP, we can still organize the configuration. But as I said, if you need further information, we can always provide it separately. These type of chargers, again, they're very similar. What we can do is we can, for example, print your logo at the particular areas, or for any customers, depending on the requirement. So if the EV charger is to be situated in the workplace or in the public access places. Now we're moving on to the more important area, which is safety, and there have been lots of discussions on safety of the EV chargers and how do they need to be protected, and there are a few different upgrades, what type of RCDs and so on should be used. And at this stage, the RCD that has to be used is type B RCD, and it has to be installed at the point of supply. One of the main advantages of type B RCD is that in opposed to the standard RCD, which works only on the AC circuits, the type B RCD will be protecting you on both pulsating, alternating, and also DC current as well. So we can supply RCDs with that RCD can be built inside the actual EV charger, but you still need to have RCD type B on your point of supply as well. Now, also one unique option that we can also provide is what is called self-reclosing RCD option. Might sound a bit scary to some people that when they see self-reclosing RCD, but the purpose of this RCD is to constantly monitor and check the state of your installation, and it will self-reclose. It does have a small motor inside the RCD and a breaker. This is sort of like a configuration the way it looks like. So it basically got three parts. One is the standard circuit breaker. Then it's got the special device that will reclose the breaker, but it will reclose it only once the fault is not there. Basically, practical application for something like this could be, for example, let's say on Friday night you have someone coming in with a faulty cable to charge their EV car, or faulty socket on their car or anything like that, and the RCD trips. Then once it trips, of course, you need to get technician to come and check the operation and test the system and reclose it. With this particular system, which is of course optional, is once the faulty unit has been unplugged, the unit itself will do a number of tests, and it will reclose that RCD only in the event that the fault is definitely clear. So obviously there is saving there on the operational expenses. That means that you don't have to send the technician. So as I mentioned earlier, if fault like that happened on Friday, of course you can send someone, technician that might be on call out, but in probably some of the cases the situation would happen that might have to wait till Monday or something like that. We do have our 24/7 phone line available with any of the EV chargers that we provide, but we can't comment on any other suppliers. So this would cover this type of the safety protection. And I will now move on to the different areas of evaluating the power availability and what size EV chargers you can use in your installations. For instance, we also do units that you can see down here. This is the EV charger, and on top of the carport, which could be in the car park, actually there are solar panels, and those solar panels are charging the batteries, and those batteries will supply the power for the EV chargers. So we can also provide you with information like that if there are some serious limitations in the power availability on your site. Now, the other optional devices that you can get with EV chargers are low temperature kit, which probably wouldn't be so important in New Zealand. As I mentioned earlier, you can have a safety protection inside the EV charger, but by New Zealand standard, you still need to have a RCD Type B charger at the point of supply. One other area which is quite important is the surge protection. So we can have that optional inside the EV chargers or also at the point of supply. And we will cover also area of the surge protection, and our surge diverters and surge filters are coming with the capability that we can monitor surge diverters and surge filters and their states through Bluetooth communication on your phone. Basically, you would download a free LPI app, and you can see exactly how many surges did you get, what's the temperature inside the surge unit, what's the power quality, and also what is the maximum voltage and minimum voltage that your EV chargers has ever experienced. Then you got optional modem for the wireless connection, and anti-vandal keys. We'll cover that in a second, and different type of cables that are available. Again, as mentioned earlier, we can customize any of chargers with putting any customer logo on there during the manufacturing. And this is what I mentioned earlier on the anti-vandal key that we can introduce. Like some different suppliers, you can always, for example, lift the handle to charge your car. With our one, you can choose that option. Let's say, for instance, the plug will be locked until you swipe your RFID card. So that's the optional. We can set that up in a software depending on your requirement. So all these things are optionally available. This is just now we're slowly moving on to DC chargers that are there's a number of different ratings. We can at this stage we can offer 50 and 150 kilowatt chargers, and they can again be used in both public and different areas or the different companies. There's lots of questions in the market on people asking how long will it take my car to charge it up. This is just an illustration of different size EV chargers and how much time will it take to charge the car. But again, if you need any further information, we can provide you this separately, or you can contact Mike for any further details, and he can provide you a copy of this presentation as well. Now, with big DC 50 and 150 kilowatt chargers, these are some of the areas when you're making decision on purchasing your EV chargers. Some of the areas might sound simple, but let's say these floating cables might sound simple comment, but it is important that they are floating, that they're not rubbing against the floor, that they are not that you're avoiding any rubbing and obviously damaging the cables. What's the access to the units, and our particular units are configured in a way of the module. So that means for a few reasons. One is for potential servicing. So if there's any requirement for servicing, we don't usually muck around too much on the job. We just have a spare unit, and it's hot swap or replaceable unit. And also having these things in individual modular units, the advantage is that the actual unit will be much more efficient, which of course means reduction in your power bill. What does it mean is, let's say if you have 450 kilowatt unit, if you have 350 kilowatt units, if the requirement for charging is just for the smaller car, not all 3 units will be running. They will be just idling and not using power, or using minimal power, while only 1 unit will be engaged. This is just a graph of just giving you idea of the efficiency and with the power module technologies. Lots of people are questioning these days user management and what can you do. As I mentioned earlier, this open charge point protocol is quite important, that when you're selecting the supply of your EV chargers, that you ensure their chargers are compatible with this protocol. So with our softwares and availability for the user and for the car park operator, we can provide all different type of options, but it's important that you know what is available and what your requirements are. Do you require public visibility? Do you require billing? Is it important that you can provide remote connection through modem and so on? Now, another thing is, as I mentioned at the beginning of our presentation, was at the beginning of the presentation we were talking about power available in the particular facility. So once we do monitoring, we will assess what the requirement is. So basically from here you can see if this is your building, we would install the CTs that would monitor power usage of your building and electric vehicle charging points, and we will interact all that with the main supply. Why is this important? For example, if you have an existing building and you don't have much capacity on the power side, then we would introduce this dynamic load management system, which will allow number of different cars to be charged at the same time, and that you won't trip your power supply. So basically this short video, hopefully you can all see this video. So what it means is you can see now in a second there will be first car approaching there, and it will start charging it. And this is without dynamic load management, and as soon as you get the fourth car coming in, the main supply overload will trip, and basically you would lose power to all of your cars. But if you have the dynamic load management, our software and control system will ensure that as number of cars that are on charge is increasing, system will slowly adjust each of the EV chargers to the slightly lower capacity, and it will allow all those chargers to be charged simultaneously, and as any of the car is full, it will automatically increase the charging rate for the other cars. So this is quite important, and then the system also comes with different type of the configuration as well. And this would be sort of software capabilities where you can see, you can set the reports, you can check the customer invoice or operator invoice. So that basically means that you can be in charge of your, say, if you are the owner of the car park, or you might be owner or landlord of the apartment building, so you can access your main invoice, and then you can see the customer invoice as a separate area. So that area we covered. Also, it's important to mention that excuse me on the details of, there is few Spanish words in this slide, but basically just showing, this is slide from satellite image of Spain, and it's just showing the area when the epidemic was introduced, basically week after not many cars were on the streets. You can see all these red areas are introducing the pollution, and you can see what happens when you remove number of cars from these areas, how much reduction in pollution, and that means also carbon dioxide emissions will be significantly reduced by introducing EV cars. There are also different theories on disposing on the batteries for EV cars and so on, but that comes to sort of different topic and different discussion as well. Now the EV chargers, like any other equipment, it is important to protect them from any surges that could be caused by building inside, or surges within the building, or surges external to the building that could be caused by either lightning strikes or car hitting the power pole or anything like that. And obviously, if you invested into EV charger, you would like to know that your EV charger is also protected against the surge, especially some of the big DC chargers that can, as I mentioned, they can be quite expensive. With in our range, as far as I don't know, I can't comment too much for the other areas, but we start basically from small chargers, $650, but then some of them are about $40,000, $50,000. So you definitely want to want to think of protecting your investment, and some of the surge protection can start from $300–400, and obviously when you compare that with your investment of $50,000 for EV chargers, it's well negligible. But as I mentioned earlier, these are all the options that we can include either inside the EV charger, or it can be done at the point of supply. As far as the surge protection is concerned, there's a number of different types of surge protection available, but obviously any surges that are entering your equipment or your facility can possibly cause personal harm to your staff and people that are charging using EV chargers. It can damage the equipment, and of course it can cause potential fire as well. And from the operational issues, obviously there would be system downtime. So if you're charging customers for EV charging, you would be losing money by not being able to collect that revenue. Again, there will be also data corruption, and if the surge arrives to your EV chargers, which might be connected, if it's not through wireless modem, if it's connected through your Ethernet cable or through your mains cables, it can get coupled surges into your main building and into your server room or anything like that. Also, any damage due to surges will cause unscheduled maintenance, which again it will cost money. There's a number of different type of surge protection, depending what class required and so on, what sort of level of protection you require. And again, we can address that in different areas and so on. It's important to mention that there are two types of surge protection. One is surge filters, and the other one is surge diverter. Surge diverter is most commonly used area, and this will just concentrate quickly on this graph. So if you don't have any surge protection, if you have a surge at your EV charger, potentially your charger would see around about 6,000 volts. Mind you, this 6,000 volts, it's not sustained voltage, it's very short duration. It's only a few microseconds, but sometimes for the electronic equipment, it's quite enough to cause the damage, mainly due to what we call dV/dt, or fast rise time of voltage, where you can see that voltage would go from 0 to 6,000 in no time. So if we install the surge diverter, this would be the graph, or what would happen. If you have a surge diverter installed at your charger, the surge will be reduced to 600 volts, still quite an achievement from 6,000 volts to 600 volts. But the thing is, surge diverter will do nothing for this fast rise time of voltage curve that you can see, and your equipment will still see that surge. And this is what we call a dV/dt. So if you require superior surge protection, then you should look at surge filter, which is particularly more cost effective on any currents up to 125 amps. Very compatible with the pricing of the surge diverter. But main advantage of the surge filter is that it has LC circuitry, so it's got the capacitor and inductor. It also had metal oxide varistors on front and back end. But main advantage is, as you can see here, that let-through voltage will be only about 230 volts when compared with the 600 volts with the surge diverter. And one of the main thing is that you can't see here this fast rise time of voltage. And this fast rise time of voltage that surge diverter can't do anything about is what normally kills CPUs or sensitive electronic equipment. So if you want to protect your electronic equipment, what it could be touchscreen on your EV charger or any display or anything like that, you should consider surge protection, either diverter or the filter. But as I said earlier, this is all optional, and you can request that from your EV supplier. As I mentioned earlier, our surge protection is coming with free Bluetooth app. So this is how your display would look on your phone, and it will show you metal oxide barista status. So it's a free app, so you just download it from internet, and you can see your, as long as you're within 15 meters of your EV charger, you will be able to see what the status of the metal oxide baristas is. You would see what's the power quality, which means if you do have any disturbances or any anomalies in your power supply, it will show you what was the, as I mentioned, how many surges did your EV chargers experience. It will show you also what the temperature inside is, and it will tell you what was the maximum voltage and what was the minimum voltage that your EV chargers has experienced. So it's quite useful in diagnosing or locating possible problem with your EV charger, what has happened, or if you need to go back to the power supplier and discuss it with them, was there any surge or anything like that. We did have some requirements from people that, for example, that we supplied the UPSs to. They asked us if we can install these surge diverters inside their units. Just to also mention, our surge diverters with these single-phase surge diverters or filters, they're starting from around $150. It's a DIN rail mounted type. So as I mentioned, we've been requested to install these, as some of the previous UPS suppliers would claim the surges on, and they wouldn't honor the warranty because they would claim there was a surge what damaged it. So if you have a piece of equipment like this installed, you can prove to your supplier that, well, you can see there were no surges at all, and they would be basically proven that they have to replace or repair the units or whatever the case is. But again, we can provide you more information if and when required. I'm just checking on time. We are about 42 minutes, so I will be wrapping up shortly to leave some time for questions. And yeah, as mentioned earlier, these are the this is sort of plan view of these carports. So we can provide the full, we actually provide this type of carports as well, with chargers built in, with the solar panels on top. So if you require any information, again, feel free to contact us or get in touch through Mike, and we can provide you more information. But this is quite useful, that you can even have a combination of the power supply to this unit, so mains power supply and battery storage that you can use from the, basically using the free power from the solar units. So I would now conclude slowly with my presentation, and hopefully we didn't go too much over time. I think we did go about five minutes over time. Mike, are you still there?
Yes, I'm still here, riveted to the screen in the presentation. Thank you very much, Gordon, for that. That was very informative, and I know because of the time restrictions, then you haven't gone into some of the detail that I know you'd really love to go into, and I would invite anyone to contact you for more detail on that. We do have certainly one question so far that's come in, and I'll remind the audience, please, you can either type in a question or raise your hand on the hand icon that you see in your little dialog box on your screens. And I'll open up the mic if I can to allow you to ask the question in person. And I'm going to test the system briefly now. We do have a question in from Paul Webber, but I've got two pieces of information in front of me, one saying that Paul has left the presentation, but Paul is also listed on the attendees. So bear with me a moment, please, everyone. I've now opened up Paul's microphone. Paul, you're actually, if you're still with us, you're self-muted at the moment. And in fact, you're now with us, I can see. So Paul, as you're there, would you like to ask your question yourself, please?
Actually, I had to leave the presentation to drive, but I've written my question down. So perhaps you could ask the question, and I'll be listening in, and I'll also check on the recording later.
Will do. Thank you for your conscientiousness and listening to us while you're in the car. So I will ask Paul's question on his behalf. Paul is from Ridgewood White Limited, and the question is, does your dynamic load management share power between the building and the car parks in real time? That is, when building demand decreases, does the budget for chargers increase, or does it share a fixed charging budget between the chargers?
Does it share the? Do you
Is
mind
there a
just
limit
repeat?
on the? I read that as being, is there a limit on the power that's going to the building and the chargers?
Well,
and
we're
therefore,
definitely monitoring through the CTs that we will install. We are monitoring the power consumption that's coming into the building, and whatever the contractual power or what's the demand power of the building. So we will monitor that, and our device, either through the maximum demand operation unit or through the dynamic load management, we will ensure that none of your protection devices will trip on the overload. So we will keep that dynamic load management system, will ensure that you will not trip the supply to your chargers. I'm not sure if I'm answering that question correctly, because he was mentioning something to do with the budget between the two buildings. Was he talking something about budget?
I think in terms of budget, it was to do with an allowance of power as opposed to a financial budget.
Oh, I see. Yes. Okay. Yeah. But anyway, as I said, we will control. I can address the particular situation and we can analyze it. But the answer is yes, in short. And our dynamic load management system, that's the purpose of it. So it will take care of the power that is available. And as I said, every building needs to be evaluated on its own. It's hard to set one rule would fits all. It depends how much power you require, how many charges you want. But the answer is that's the purpose of the dynamic load management system.
Okay, thanks for that.
Paul can power all of your charges.
Yeah, Paul can easily follow that up, I'm sure, if we didn't quite get to the nub of his question. If I may indulge myself with a little question of my own. We see vehicles advertised on various platforms, and we can purchase vehicles which have different sockets, which obviously have different types of plugs to go in them.
That's correct.
What's the recommendation around the types of socket, and is there any difference when we're looking out to buy an EV as to which type we should be wary of or look for?
Type 2 sockets and plug is predominantly used, but obviously there are type 1 and type 2, and basically the difference is one area is for European cars and the other is for the Asian manufactured cars.
Okay, but if we're looking at installing a charger, how do we cater for the fact that we could be looking at vehicles with the different types of plug socket?
Again, let's say our engineer, and I believe with any other reputable companies, our engineer will go on site and have a chat with the facility manager, or through video conferencing these days, I suppose, to keep the social distancing. But we would ask you, what sort of cars are you expecting? That's why I said it's important to evaluate. Are you going into the, are you installing EV chargers at supermarket area, or are you installing chargers at, say, council buildings? So for example, if it is for the council, different type of councils, then they would use particular type of the car, and quite often they use only one type of cars. and we will make sure that obviously you would get the sockets or majority of the sockets for this type of either 1 or 2. But number 2 plugs are predominantly used, and but it depends what sort of car you purchase, obviously, or you intend to use. I mean, if it is supermarket, again, you would say that number 2 would be, maybe you would install maybe 70 or 80% of number 2 type 2 plugs or sockets, and the rest you would use as number 1. But we can evaluate that. Our engineer will evaluate each individual case and the requirement.
Okay, and
Sorry,
in
does that
terms
answer the question?
yes, I think so. Thank you. In terms of home chargers, what
Yes.
is the relative merits of installing a specialist charging unit versus plugging it in to your 3-point socket at home?
Well, usually your 3-pin your power point at your home is rated at the maximum of the breaker that's feeding it. It's 20 amp normally, 16 or 20 amp, and the socket is normally suggested to use not more than 10 amp out of it. So you have a limitation there on how much charge you can put out of it. So it's always recommended. It is a bit more tricky on the retrofit or for the existing house, but it is important to note that when you're building a new house, to allow extra power or extra cable that you could charge, or you could install, let's say 7 kilowatt charger or 12 kilowatt, depending whatever the requirement is for a car. But always your local electrician can, I won't say easy enough, because he would need to make sure that there is power available, but he would then run bigger cable to the different EV charger. Let's say that e-home charger that I showed you at the beginning, that's usually for the home. That's the cheapest one, from $650, and then electrician would ensure that he does have a bigger cable that's going to run directly to that charger, and it won't be looped to any other power points. Another thing is, obviously, if you have your power points in a garage or wherever you're running the cable from, it's important that if you start running drawing more power, then obviously you will trip your breaker in your domestic switchboard, and then it will mean you would also lose your other power supplies from the other power points. So it's always recommended to have a dedicated small EV charger. But again, as you said, some of the cars, they would automatically adjust, and they would draw only enough power what's required for that particular battery in the EV charger. But it's definitely always best practice to install separate EV charger with a separate circuit dedicated only for that EV charger.
Okay, that's very helpful for me. And interestingly enough, we've got a conference presentation at our conference next week about vehicle-to-grid charging, yes. Which is something that Russell is interested in as well, I think. Russell, I'm just about to open your microphone. If you could introduce yourself, please, for those of you who don't know you. Russell, you should be live.
Okay, yeah, good afternoon. Thanks for your presentation. I'm Russell Bailey. I'm the Energy Manager at the University of Auckland, and I've got an electric car and had the home charger for 3 years now. I'm aware that the next generation...
Do you mind, Russell, do you mind speak up a little bit?
Okay, how's that?
Yep, that's better. Thank you.
Yeah.
Yes.
So, Energy Manager at the University of Auckland, privately own our own electric vehicle, have the wall charger at home, been following the technology. I understand that the next round of technology that's about to come on the market here is a DC to AC box that you can put on your wall at home, so you can plug your car in using its CHAdeMO socket, and then that will enable you to have vehicle to house power by drawing the DC from the vehicle's drive battery through the DC to AC box and into your domestic switchboard. Do you have any comment on those products, and have you got one of those coming into your lineup soon?
Not particularly in our line. I will, obviously that's really fast growing area and everything is moving quickly, and also the other thing is what they were talking about, the contactless charging as well. That's also the new technology. To answer your question, this is new technology and we don't have this in our product range, but I will talk directly to the factory and hopefully have a bit more information for you maybe tomorrow. But the other, talking about new technologies, there were some talks even about the induction charging as well, where basically you would have a more or less like a primary transformer in your garage floor and the secondary transformer in your car, and then you would just drive a car. Because there were some comments, let's say for instance, you come in your garage and I'm not saying necessarily woman or wife coming from shopping, you know, taking the shopping out of it and forgetting to plug the charger in, and in the morning you want to go to work and the car is empty. So they were justifying using that induction type of charging also, that you would avoid a potential problem of forgetting to charge your vehicle, that automatically as you drive it inside the garage, the car would automatically start to charge. So again, these are also new technologies, and we are following obviously new technologies, but questions to your answer to your question, what you said, for more information on this particular type of technology, we don't offer that type at this stage, but as I said, I will find out more information and come back to you, if not tomorrow, then definitely during the course of this week.
Hey, thank you.
You're welcome. Yeah, sorry I couldn't help there, but as I said, we can't keep up with every part of the technology.
Thank you, Russell. Now, I don't see any other questions or hands raised at the moment. And as we're approaching 5 o'clock anyway, it falls on me to say thank you very much, Gordon.
You're welcome.
Great to have you with us today. And I think we've all learned that there's so much to consider when you're thinking about installing an EV charger. And so it pays to talk to somebody who knows what they're talking about. First, do it before you make the mistakes, I think, isn't it? It's the key message. So thank you to you for that information. And as I said earlier on, I'm sure Gordon's happy to take any questions if anybody has any follow-on questions. Thank you as well to the audience today, who've been very attentive, I'm sure. Believe it or not, on the software we have here, we can actually see who's paying attention to the presentation, okay, and who's maybe doing something a little bit else and answering their emails. So we've had quite an attentive audience tonight. It's a testament to the topic and your skills of presenting it, Gordon. So thank you to the audience once again. Thank you to you, Gordon. We'll pass on any messages as they come through, obviously. And I'll just like to wish everyone a pleasant evening. Don't forget, our conference registrations are closing in 30 seconds or so. That is if you want to enjoy the discounts. Registrations will remain open beyond today, but there won't be any discounts, member discounts or anything, I'm afraid, or concessionary rates now because of our systems constraints around registration. So thank you once again, everyone. And hopefully you'll all be installing EVs and buying EV chargers and buying EVs within the next 12, 18 months or so. And I'll just finally wish you all a good evening, and thanks for coming along, and watch out for any more webinars that we have coming up. Thanks, everyone.
Thank you very much to everyone, and have a good day. Thanks, Mike.
Thanks, Gordon.